This is the solution of the problem of the crate on an incline when there is friction and we are looking for mu k. Let's start by first drawing free body diagram. So for this, kind of just draw the incline. Here's the crate, which had a mass of 7 kilograms and is being pulled 70 newtons at 10 degrees. So you were told it is accelerating up and it's moving up the incline. We need axes first. First, let's put our 20 degrees here. Since it is moving up the incline, the best choice of axes, x parallel to the incline up, y perpendicular up. So let's draw all the other forces and then we can resolve into components. So the other forces that are present: mg, which is the weight straight down, n, perpendicular, Fk, opposite the direction of motion. Remember, friction is opposite motion, not opposite applied force. Since the motion is parallel to the plane up, friction is parallel to the plane down. So now we have to resolve into components. Again, I'm going to go around in a circle starting up here. Here's 1, 70 newtons cos 10, 70 newtons sine 10. N is already in components. Fk is already in components because they're on axes. And then we have the weight. These are the two components, one perpendicular, one parallel. Make sure you really notice the arrows. 20 degrees, 20 degrees, mg cos 20, mg sine 20. And just as a side note, since we have our triangles, you really need to, at this point in the course, to be able to quickly determine components. You can't spend extra time determining sines and cosines. You really have to know opposites and adjacents or you'll never get these problems done. So when you see this, this is about the most you will ever find on a picture. You really have to make sure you're organized. So what I'm going to do is underline everything in the X if I can. Here's something, at least best I can. There's an X. Here's an X. And here's an X. And then maybe I'll put a little star next to things in the Y direction. And again, if you're doing this with multiple colors, it's pretty good because then you can actually circle things in different colors or write things in different colors to keep things organized. So we are looking for mu k. The only way of finding mu k is by using this equation. Fk is mu k times n. So mu k equals Fk divided by n. So this really tells us how to approach the problem. We need to get Fk, we need to get n. So how are we going to get Fk? Well, Fk is along the x-axis, so let's start with this. Sum Fx equals max. Really, friction problems are Newton's second law problems. So let's not make more out of it. The left side says sum the forces in the x direction according to sine. So now we'll look for everything that we underlined. 70 newtons cos 10 minus Fk minus mg sine 20, since mg sine 20 will point down, equals m, 7 kilograms, and the acceleration is in the x, 1.94 meters per second squared. So look, we know mg. mg, when you multiply 7 times 9.8, is 68.6 newtons. So look, we could also calculate the 7 times 1.94 if we need to. But no matter what, we can solve this for Fk. We need to see it all into an equation. Fk is 70 newtons cos 10 minus 68.6 newtons sine 20 minus whatever 7 kilograms times 1.94 is, which is 13.6 newtons. We can make sure we see it up here. And when you solve this for Fk, you end up with 31.9 newtons. So that's going to go in here. So now we need N. Well, we've already used the X equation. Let's use the Y. Sum Fy equals MAY. Same kind of approach. If you have things set up right, you should always start with N, and N should always be positive because we're always drawing it in line with our y-axis, pointing in the same direction. So we're going to end up with N plus 70 newtons sine 10 minus mg cos 20 equals 0. There is 0 acceleration in the y direction. It is not crashing through the plane. It is not flying off the plane. We will not have acceleration in two directions as long as you have your axes set up properly. This is why we need our axes parallel and perpendicular to the plane. If you made axes that looked like what you would call standard axes, like this, you will have acceleration in both directions. That would be bad. Let's get rid of that right away. So now we can solve this for N anyway. N is going to be mg, which again is 68.6 newtons, cos 20, minus 70 newtons sine 10, and we end up that the normal force is 52.3 newtons. That will go here. Now it's trivial to get mu. Mu k is 31.9 newtons over 52.3 newtons, or 0.610. Remember, no newtons. Mu k is dimensionless. It is a ratio of a friction force to a normal force. So these problems are longer. There's always 3 equations, but if you're very logical and very careful drawing your picture and labeling what are the forces in each direction, they're very doable in a reasonable amount of time.